Okay, so in the previous lesson we came across the 1D direct delta function. Just to write out again what it is, so we have delta x is going to be equal to 0 if x does not equal 0, and it's equal to infinity if x is equal to 0. And we also found that if we integrate from minus infinity to plus infinity of delta x dx, what we found is the area on the linear distribution, which is given by 1. Now what we want to do here is let's consider that we've got some continuous function f of x. Okay, so it's a continuous function. That is, it's not a delta function. And let's say we multiply f of x by the delta function, delta x. Okay, what do we know? We know that the product of this is going to be equal to 0 if x does not equal 0. Okay, because remember, the delta function is going to be 0 everywhere except at the origin. So now what we can simply write is that our continuous function x of f multiplied by the delta function x is going to be equal to the value of that function at x is equal to 0 multiplied by the delta function. Now that's if x equals 0. Okay, so this is quite important. Okay, so essentially, since we know that the delta function is going to be 0 everywhere except at the origin, we can just write the product of f of x delta x at x is equal to 0 as the product of the delta function multiplied by that function at x is equal to 0. So it's that value that that function would assume as if it was at x is equal to 0. Now, we can also take this a bit further. We can also do the integral from minus infinity to plus infinity f of x delta x. And here what we find is that we can bring the value of our function at x equals 0 outside the integral. So we're left with the integral between minus infinity and infinity of delta x. We know that that is going to be equal to 1. So now what we just found is this is going to assume the value of our function at x is equal to 0. Okay, so just to recap, the integral from minus infinity to plus infinity of the product of a function with the delta function will essentially just assume the value of that function at x is equal to 0. We can also shift the delta function. So now let's suppose that we have our delta function is now located at some point A. Okay. So what this is now is this is our delta function of x minus A. It's just been moved. So we can now write something similar to what we had before. So now what we have is the integral from minus infinity to plus infinity of delta x minus A dx. Well, this is still going to be equal to 1, okay, because we're taking into account the delta function. We can also write the integral. We've got our function f of x again. So it's a continuous function multiplied by our delta function at x minus a. Well, we can now write this as the value of the function at a multiplied by the delta function x minus a. So if we take the integral of this between minus infinity and plus infinity, what we find, this is dx, what we're going to find is just the value at x is equal to a of our function, f of a. Okay, so this is quite important. Now, what we want to do is just put this into practice so you can see how it works. So let's consider that we have the integral from 0 to 3 of x cubed by the delta function of x minus 2 dx. Okay, so what's the solution to this going to be? Well, the delta function is going to pick out the value at x is equal to 2. So our solution is going to be 2 cubed, which is going to be equal to 8. Now let's suppose that instead of between 0 and 3 we had the integral between 0 and 1 of x cubed by delta x minus 2 dx. Okay, so what is the answer to this going to be? Well, this is going to be equal to 0. Why is it equal to 0? Well, we're not covering the point at which a delta function picks out the value at x is equal to 2. We're only going between 0 and 1. Okay, of course, if we went between 1 and 3, 1 is a lower limit, 3 is the upper limit, our answer would be 8, because the delta function will pick out that value at x is equal to 2.